So in last class we discussed about introduction of IoT, followed by that the challenges and issues in IoT and what are the various examples of IoT. Okay, so followed by that the next topic is physical design of IoT. Physical design of IoT. My slides are visible, ma'am? Yes.
Yes, ma'am.
Yes, ma'am. So the physical design of IoT, this comprises of the structure, physical structure. So there we have two components. One is things in IoT and second is IoT protocols. Okay. So things in IoT, already I defined, I have given enough definition about things. Just I'll recall what you're calling as things. Okay, so all the physical objects like electronics, software, sensors, network connectivity, everything is said to be things. Okay, and we discussed a few examples related to the related specifically also on the day. And so here we discussed about things in IoT, and the second thing is IoT protocol. Okay, so as a whole, it comprises of the various layers like link layer, network or internet layer, application layers, and transport layers. Okay, and so this is a general block diagram of the IoT devices. It is having a processor, connectivity. Processor is your CPU, connectivity like a USB host and Ethernets, audio and video interfaces, HDMI, how much, like what are the specifications behind everything is there, and IO interfaces like sensors, actuators. So there we have UART, SPI, something. So we'll discuss everything detailedly in the further chapters, right? And memory interfaces, NAND or NOR gates, and graphics GPU, and storage interfaces. So usually, if you're taking a particular IoT device, it may consist of few components like that. Not all, based on that. Okay, so based on the design of the IoT. And next will come for again, I told you the physical design comprises of two things. One is things in IoT and second is IoT protocol. These are the things how, like what are the, how the physical structure would be, you should know that, right? Connectivity, processors, audio video interfaces, IO interfaces, storage interfaces, memory interfaces, as well as graphical. Okay, so the basic like memory interfaces is required for all IoT devices, right? Storage interfaces is also required. We need certain connectivity. We need processor to manipulate our commands, manipulate our programs, right? Audio and video interfaces is also required. Okay, graphics is optional, so based on that we can use. If you are making use of that IoT device for multimedia purpose, we are in need of all these things. Fine. Okay. We shall come for the things in IoT again. So the things in IoT usually refer to the IoT devices which have unique identities and can perform remote sensing, actuating, and monitoring capabilities. Okay, so usually it refers to the IoT devices. I told you already, all the IoT devices have unique identification, right? So which could be capable of performing different things like remote sensing, actuating, and monitoring capabilities. So what are the other things we can perform with IoT? So the next point, the IoT devices can exchange data with other connected devices and applications, or control data from other devices also. Okay, for example, if you want to monitor the heart rate of a patient, okay, so it is possible with the help of the IoT devices, and process the data either locally or send the data to centralized servers. Okay, so based on the usage, those two things, these two things are possible. First one is exchange data with other connected devices and applications, or collect data from other devices. Second thing is it will process the data either within that, or it can make use of the common server. Okay, so that is what given. And an IoT device may consist of several interfaces for connections to other devices. It may be wired and wireless also. Okay, so how it would be connected? The IO interface for sensors, interfaces for network connectivity, memory and storages, and audio video. So those two components only I have shown you in the diagram. Okay. Next thing is IoT protocols. IoT protocols. So how will you define protocol? Protocol is defined as set of rules used for communication. Protocol is defined as set of rules used for communication. So what are the IoT protocols available? Link layer is one of them. Okay, you just recall this layout. So here I have given everything. What comes in link layer, what comes in network and internet layer, application layer, transport layer. So the physical design as a whole, it comprises of the things in IoT as well as the protocols, right? We will see one by one. So these are the IoT protocol. First we'll define what is link layer. So the link layer protocol determine how the data is physically sent over the network's physical layer. For example, what type of medium you are using, like a copper wire or coaxial cable or fiber optic cable, whatever, right? So the link layer is protocols determine how the data is physically sent over the network. Okay, network physical layer. And this other functionality of link layer is this will determine how the packets are coded and signaled by the hardware devices over the medium to which the host is attached. Okay, so the link layer determines how the packets are coded and signaled by the hardware devices over the medium to which the host is attached. Okay, host is your thing which is meant for communication purpose, and how the informations are transferred, how the packets are transferred from source to destination, that is also there. Okay, so the link layer performs these two functionality. How the data is physically sent over the network layer or via the medium, and second, how they are coded and signaled by the hardware devices over the medium. Okay, and this is another layout of IoT protocols. So I told you there are 4 layers available: link layer, network layer, transport layer, and application layer. So the link layer is said to be the lower level layer. So there we have 802.3 Ethernet, 802.16 WiMAX, 802.11 Wi-Fi, what you are using at your homes, 802.15.4, that is LRWPAN, and 2G, 3G, something like cellular. Everything comes in link layer. Okay, how they are physically connected. Fine. The next is network layer. There we have IPv4, V6, and 6 low pan. IPv4 internet protocol versions. Okay, V4, V6, and 6 low pan is another. So all the protocols we will discuss detailedly in further modules. Okay, separate modules for everything. And transport layer, transmission control protocol, and user datagram protocol. Okay, so these are the basic things behind a network. And application layer comes HTTP or hypertext transfer protocol, and COAP, constrained application protocol, WebSockets, message queue telemetry transport layer protocol. So many things are there. So there that also be discussed in further chapters. Fine. So these are the protocols involved. And what are the characteristics of 802.3 Ethernet? Okay, so can any one of you read it? These are some properties. We should know these things. That's it. Yes, Shakshi Narayan. Can you read the feature of 802.3 Ethernet?
Yes, ma'am.
Yes,
IEEE 802.3 is a collection of wired Ethernet standards for the link layer at a rate of 1.25 Gbps. The shared medium in Ethernet can be a coaxial cable, twisted pair wire, or an optical fiber.
Okay, thank you, Shakshi. So 802.3 Ethernet is said to be one of the link layer protocol. So it's a collection of wired Ethernet standards for the link layer, which provides speed at a rate of 1.25 gigabytes per second. Okay, and the shared medium in Ethernet can be anything like a coaxial cable, twisted pair wire, or optical fiber cable. Okay, and next is 802.11 Wi-Fi connection. So it is a collection of wireless local area network communication standards, including extensive description of the link layer. These standards provide data rates from 1 megabytes per second to 11 Gbps. Okay, so for example, Hathway is one of the network where we can provide connection with the components involved at our home, like laptops, tabs, your system or mobile phone, whatever, right? So this is said to be another. So what is that 802.3, 802.11? Those are the specifications for the particular thing, like Ethernet. We indicate with that specification. Okay, ma? So 802.11 Wi-Fi is a wireless local area network communication standard, including extensive description of the link layer. So what is its range? Okay, frequency range is given. And next, WiMAX 802.16. So it is a collection of wireless broadband standards, includes again extensive description. And this WiMAX standard provides data rate at 1 GB per second. Okay. And the next comes 802.15 LR low thing. And there we have a wireless personal area network. So what are all those things is given? So anyone can read, I think. Aviral Goyal. Yeah, can you read that? The feature of 802.15.4.
Yes, ma'am.
Yes, ma'am.
IEEE 802.15.4 is a collection of standards for low-rate wireless personal area network (LRWPANs). These standards form the basis of specifications for high-level communication protocols such as ZigBee.
Okay.
LRWPAN standards provides data rates from 40 kilobytes per second to 250 kilobytes per second. This standard provides low cost and low speed communication for power and constrained devices.
Okay, thank you, Aviral. And so here they have given 802.15.4 low rate wireless personal area network. So it forms the basis of specifications for high level communication protocols such as ZigBee. So we'll discuss ZigBee, what are the properties behind ZigBee, what is ZigBee, everything. And this low rate wireless personal area network, it provides data rate from 40 kb per seconds to 250. Okay, and this standard provides low cost and low speed communication for power constrained devices. Okay, ma'am? Fine. And the next is link layer protocol relevant to the context of IoT. So 2G, 3G, 4G mobile communication comes in this category. So there are various standards available here. 2G including global system for mobile communication, your GSM and CDMA. Okay, carrier division multiple access protocol. And 3G including Universal Mobile Telecommunication Service UMTS and CDMA, and 4G including long-term evolution. So the IoT devices based on these standards can communicate over cellular networks. Okay, you people are working with that, so you may be very much familiar. So it also comes in the category of link layer protocols. Fine. The next is network and internet layer protocol. So you just recall the diagram again. So there we have IPv4, IPv6 and 6LoWPAN. Okay. So what are all those things? The network layers are responsible for sending of IP datagram from the source network to the destination network. As you know, if you want to communicate two systems, for example, A and B, A is said to be the source machine and B is said to be the destination machine. So how the transmission takes place between both of them? So the network layers are responsible for sending that IP datagrams, internet protocol datagrams from source to destination. Okay. And second thing is, this layer performs the host addressing and packet routing. Okay. So host addressing and packet routing in the sense, what is the ID for the particular transmission? Okay. So how the data, what is the ID for the particular data? Okay. Specifically, they will allot some unique ID. And how the packets are transmitted, you know, right? Transmission control protocol is meant for connection oriented service. So there we'll send the information from source to destination. And the datagram contains source and destination addresses which are used to route from source to destination across multiple networks. Okay. And the host identification is done using hierarchical IP addressing schemes such as IP version 4 and IP version 6. Okay, so internet protocol. So whatever we are working with your internet is said to be example for this host addressing and network name. What we are using with net. So how the informations are transmitted, how the informations are reaching the destination, everything can be done. Okay, so here I have highlighted few points which is not available in your book for better understanding only. So this is responsible for what is the functionality of network layer. You should know it is responsible for sending the IP datagrams from source to destination, and this is meant for functioning with the host addressing and packet routing. You should know what is addressing. Each and every data packets may have unique identification. With that only, it could be capable of traversing from source to destination and how the packet will be routed. Okay, and the datagrams also contains a source and destination address which are used to route from that, even though multiple networks are present. Okay, this is the sender, this is the destinator. So it will properly send the information even though multiple destinations are available. That is the meaning for the third statement. And host identification is done using hierarchical IP addressing schemes. You know what is hierarchical? Parent-child relationship. So based on that, that particular ID will be created for, address will be created for all the datagrams. Okay, so that's it. And what is IPv4? What is IPv4? Internet Protocol version 4. I told you Internet Protocol version 4. And it is the most deployed IP which is used to identify the devices on a network using hierarchical addressing schemes. Okay, hierarchical against parent-child relationship. And IPv4 uses a 32-bit address scheme that allows total of 2 power 32 addresses can be generated. Okay, so whenever that particular IP is generated for all the users based on that scheme, 32-bit addressing scheme. And the IP protocols establish connections on packet networks, but it won't guarantee delivery of packets. Okay, it won't guarantee delivery of packets. It provides connection and it could be capable of transmitting, but we're not sure that the destination received all those packets or not. Okay, so that is the concept behind IPv4. And guaranteed delivery and data integrity are handled by upper layer protocols such as transmission control protocol. Okay, ma? So these are the features of IPv4. Coming for the IPv6, it is the newest version of Internet Protocol, and it is having some more features which enhances the IPv4. And IPv6 uses 128-bit address scheme which allows total of 2 power 128. Okay, so that particular addresses will be generated with hierarchical addressing schemes. And 6LoWPAN, I told you it is another internet or network layer protocol. This is low power wireless personal area network. It brings the IP protocol to the low power devices which is having a limited processing capability. Okay, so that is about 6LoWPAN. And coming for the transport layer, so diagram you should recall again. Transport layer, the next layer, TCP and UDP is required there. So what is TCP? Transmission Control Protocol. So the transport layer protocols provide end-to-end message transfer capability independent of the underlying network. So it will provide a connection using handshake mechanism. Okay, what is that handshake mechanism? Sender will send to receiver. Immediately it will acknowledge. Then the message will be receiver will receive that message. There it will send the acknowledge. So then and there it will provide acknowledge mechanism. Acknowledge is there. So we are calling it as a handshake mechanism. If you are not making use of handshake, we are calling it as UDP protocol, user datagram protocol. Okay. So you go for Google, you can search it what is TCP. You may have enough information, but we should know what is TCP. That's enough for IoT. If you are talking very much about internet, or you are going to yeah, I think TCP is also separate topic available in some of the chapters. There I'll discuss more. And if you're making use of that particular protocol for your purpose, these are the basic things in computer networks. So if you need that, you can go for a better study. Okay. So we are providing handshake mechanism. We are calling it as TCP. If there is no handshake, we are calling it as UDP. So I have indicated that also, handshake or acknowledgement. Okay, ma'am? Fine. So the transport layer protocol provides various functions such as error control, segmentation, flow control, and congestion control. Okay. So what is error control? Suppose I'm sending some message as a source machine, and the receiver cannot capable of receiving it due to some problem in the packets or in the IP address, whatever, in the network, whatever. So how the transmission control protocol, it will automatically indicates this is the error. Okay. So how it would be rectified. Okay. So those mechanisms will be immediately informed to the concerned person. And segmentation in the sense, we have some partition, right? We have some partition in the memory, and how the data are filled there, and if the data exceeds certain limit or overflow occurs for the particular data, there is no space at all. So everything segmentation, it comes in segmentation fault. Okay. And the next comes flow control. How the data are processing from source to destination on a synchronized manner. Okay. So where some interruption occurs, where the break occurs for a particular packets, everything is done with flow control. And congestion control in the sense over flooded, like all the packets are sending simultaneously. Okay. So they should reach destination within certain time. So we are rushing up. So that is said to be congestion occurs. So how we can overcome all those things? So the transport layer take care of all this error control, segmentation, flow control, and congestion control. Okay, ma'am? Fine. And this is the most widely used transport layer protocol, which is used in your web browsers along with HTTP and various applications like SMTP, FTP, wherever, right? And it is said to be a connection-oriented protocol that I insist already. So connection-oriented in the sense it provides a handshake mechanism. This TCP also ensures reliable transmission of packets in order. Reliable transmission of packets in order. It is assuring the user that particular thing would be definitely received by the destinator. Okay, that's the meaning for the final statement. And it also have the capability of detecting the errors and detecting the duplicate packets. The duplicate packets, once it is found out, it can be discarded. Okay, everything is done with the help of TCP. And flow control, I told you, it ensures that the rate at which the sender sends the data is not too high for the receiver to process. And congestion control, it helps in avoiding the network congestion and collapse, which can lead to degradation of network performance. Okay, ma'am? So what I said, I have given as a statement in a different manner here. Fine. The next comes user datagram protocol. It's a connectionless protocol. Whereas the TCP is a connection-oriented protocol. Okay. So sometimes the question will be, what is the difference between UDP and TCP? What is the difference between? Distinguish. Okay, that is also a possibility here. UDP is a connectionless protocol and it is useful for time-sensitive application that have very small data units to exchange and do not want to overhead of connection setup. And it is a transaction-oriented and stateless protocol. It won't guarantee. It won't perform duplicate elimination. The flow of informations may be in any order. We can't say it is moving in the same order, like if I'm sending from source A, B, C, D, E, the receiver may receive it in any order. Okay, so those are the drawbacks of a user datagram protocol. So usually we are preferring TCP, which enhances with the HTTP. All your web browsers are making use of that TCP. Okay, fine. The next comes application layer. I think this is the last layer for IoT protocols. So what you are doing in your day-to-day life is like games, right? You are playing with your games, and application defines how the application interface with the lower layer protocols to send the data over the network. So here we used port numbers for use for application addressing. It controls or enable the process to process using with port only. Okay, hyper text transfer protocol, HTTP. Port 80 is the identification for HTTP, and port 22 for SSH, something like that. And hypertext transfer protocol is the application layer protocol, which forms the foundation of your World Wide Web. You are using that, and it follows a request response model, where a client sends request response model to a server using commands, HTTP commands. And this is independent of other requests. Each HTTP request is independent of other requests, as you know, right? Hypertext transfer protocol. And COAP is said to be another protocol, constrained application protocol. It's an application layer protocol for machine-to-machine application. This is meant for constrained environment with constrained devices and constrained networks. Okay, and this uses request response model. So what is this request response model? Okay, so those things will be discussed in logical design of IoT. I'll tell you all these things. And one more protocol is advanced message queuing protocol. So it's an open application layer protocol for business purpose. We are using that, AMQP. Okay, so advanced message queuing protocol. So this is meant for business purpose. It receives messages from publishers and route them over connection to consumers. Okay, so this is one of the application layer protocol. And the next is logical design of IoT. I'll take that tomorrow, ma. Okay, so this is the last topic, I think. Plus, we have security issues in the first unit. So, these things are not available in your textbook and all. I'll try to send you a textbook via Gmail because it is more memory, like more data size is more. So you can go through this physical layer slowly today. What do you mean by physical design of IoT? The general overview is given here. There are two components available, things and IoT protocol. And there we have link things we have to define generally. And these are the generic block diagram of IoT device. This is for your reference. And what do you mean by things in IoT? What is the functionality of things I have given? Plus the protocols I have defined one by one. Okay. So a link layer is one of the protocol. There we have so many subdivisions like Ethernet, Wi-Fi, WiMAX, LRWPAN, and mobile communication. If you take a network, there we have IPv4, IPv6, 6LoWPAN. Okay, ma? So I have given short description. Detailedly, we'll have it in further units. Okay, don't worry about all those things. And next is logical design and security. That I'll cover in next class. With that, your first unit module is over. Okay, ma? Okay.
And when will you
book as soon as possible?
Yes, ma?
Please send the book as soon as possible.
Book, you are asking about textbook.
Yeah, ma'am. Please
Yeah,
mail it as soon as possible.
that I'll make it today evening. No problem.
Yeah.
Okay.
and when will you upload the material?
Material already uploaded. So what I prepared initially I have given, plus I am making some modifications, so that I'll remove it and make it afterwards. But as of now, it is available in your course page. Okay, fine. Can you get me, ma? Yes, your first module